Okay, on to the third problem, laying a cellular cable through a hill. You want to determine the length of the cable needed. From a point off the side of the hill on the level ground, you measure the distance to the entry point to be 56.4 meters. The first thing we need to do is we need to figure out what they're talking about here. So this hill, this is the entry to the hill here, and there's a hill going up and then coming down. So this is the entry over here, and this is the exit over here. Okay, so this is a crude two-dimensional drawing for a three-dimensional situation. So imagine you're standing over here. This is where you're standing. This is you, and then you can measure this distance to the entry of the bottom of the hill there, where the cable will go in, and over here is where the cable will come out for that hill. Says that the distance to the entry point is 56.4 meters, so 56.4 meters, and the distance to the exit point is 78.9. So you can measure the distances from yourself to the entry and the exit, 78.9, and the angle between the 2 points is 72 degrees. So this is 72 degrees. How much cable will you need? At what angle will the cable need to be laid so that it will come out at the exit point? We're focused mainly on the how much cable do you need, which means we're looking for this. Initial reaction is law of sines, sine of 72 over x, but the problem is I have neither one of these. Now there's two ways you can solve this problem. One way is with using the Pythagorean theorem a couple of different times. But another way is to use the law of cosines, which we haven't talked about yet, but it's just a formula that you can plug stuff in with. So here's the law of cosines. Now it looks complicated, but don't be alarmed. It says a squared, so if we're talking about this is just three different ways to write it. Either one of these is acceptable. Basically you're saying side length a squared. A squared is equal to the other side length squared plus this side length squared minus 2 times this side length times this side length times the cosine of A. Now the calculator will do all that for you. So this is going to be useful when the law of sines doesn't work. So in this case we can do sine of 72 over x, but I don't know either one of those angles, and therefore I can't, there's nothing more I can do. So I can utilize this law of cosines. Now let's write out, we're going to have this is x, so this is the side length I'm using, and then that's its corresponding angle, and that's the most important thing here. Whatever side is over here, the angle opposite of it is over there. So if I say x squared is equal to, I'm going to call this the b, 56.4 squared plus 78.9 squared minus 2 times 56.4 times 78.9 cosine of 72 degrees. So now we're thinking, well, that looks like a bunch of junk, but we can put that just into the calculator here. So if you take a look at 50, see if we can see it, 56.4 squared plus 78.9 squared minus 2 times 56.4 times 78.9 times the cosine of 72 is equal to 6656, let's call it. Now, this is the important part here. X squared equals 6656. So you got to remember, there's one more thing to do here, correct? I can take the square root of that answer. Calculator does most of the work for you. X equals 81.58 meters. Does it make sense that this would be 81.58 meters? I think so. The other thing they asked is, what is this angle right here? What angle should be formed with U in the entry point so that it comes out at the correct angle? So now if I'm looking for this angle, if I call this, oh, I don't know, M for Marty Jr., we can go the sine of 72 over 81.58 equals the sine of M over 78.9, and it goes pretty slick. Now, this law of cosines thing, which if you're taking this class in the January of 2015, I've written it on the sideboard for you. But what you have to remember is that this side is opposite this angle, and then the other two, they're all interchangeable. If when we get to the test, you'll be able to have this equation would be provided for you. You would never have to memorize it.